you're going to be put in situations sometimes where you're looking at a triangle like this, and maybe this one is 7, and maybe this one is 8. And we've been talking about the idea that if we made big squares off of every side that have the side length that matches this number, then the two smaller ones, this one and this one, when you add their areas up, it's the same as this area. And everybody gets that, right? Yeah. Good. So to find the areas, I would look at this and I would go, oh, well, this is 8 times 8, that's 64, equals 64. And this is 7 times 7, so that area is 49. And you don't even really honestly need to show me how you found those because they're fairly straightforward. Now I know that the area of this square is going to be 64 plus 49, which is going to be 113. Right? Does that make sense? So that part's fairly easy to find. The thing I need you to get is that this side length is the square root of this area, and this area is the side length squared. I need you to understand that relationship back and forth. 8 squared is 64. The square root of 64 is 8. 7 squared is 49. The square root of 49 is 7. Which means this side squared is 113, which means that the square root of 113 is that side. So if I were you, I would label that side square root 113 and leave it like that. That is a much friendlier and much more exact number than whatever your calculator is going to give you for the square root of 113. Does that make sense? Now, this is going to be especially useful in problems that have more than one step. Let's say I gave you a problem that looks like this. Okay? Where this is a right angle and this is a right angle. If I gave you this question and told you that this was 10 and this was 4 and this was 5, and I asked you to find this side, the first thing you'd have to do is figure out this side, right? And you would do that by thinking, well, I know the area of it is going to be 25 plus 16, that's 41, which means the side length is root 41. Leave it as square root 41. The reason why is because what you're going to end up doing is squaring those next two sides again anyways. So this you're going to think, well, 10 times 10 is 100. Root 41 times root 41 is what? This needs to be automatic. What is square root of 41 times square root of 41? I'll give you a hint. Square root of 41 times square root of 41. It's 41. And you must get that. A square root times itself is a square root squared. Does that make sense? 2 times itself, that's 2 squared. 3 times itself, that's 3 squared. Root 41 times root 41 is root 41 squared. Those two things undo each other. What is a number multiplied by itself divided by itself? Well, it's just a number. And so this is 41. That must be automatic. Because that's going to make this question super easy. 10 times 10 is 100. Root 41 times root 41 is 41. That means the area of this square is going to be 141, which means that side length is going to be root 141. Done. And you will hopefully get this quick at these questions. Now don't get me wrong, you can use h squared equals a squared plus b squared and solve this stuff, but that would have taken forever. Whereas I could do it this way and explain it. I'd like you to be able to do both. I have no idea what that sound is, but I'm terrified. Questions from yesterday that people would like to see? Yeah?
The last question.
The last question. Is there anybody else who'd like to see the last question? Good? I'm pretty sure the last question is the one with the weird 2 triangles back to back.
No, I just had no idea what to do.
Yeah, but it still is that question, correct? Yeah. Good. So, it looks like this. And then woot woot. And this one here is 13. And this one here is 5. And that guy there is 5. And I know that this equals this. And then I'm going to label everything P, Q, R, S, T. And I know that these are right angles. So, from here, looking at this situation, I should be able to start at least knowing, what do I know, what don't I know? Do I know two sides to any one triangle? Do I know two sides of any of the triangles? I'm actually going to need recognition that you're awake and that I'm speaking English. Yeah. Yeah, 13 and 5. So for triangle PQR, I know 13 and 5. The question is, do I know H or don't I know H? Do I know the hypotenuse or don't I? I do. 13 is the long side of this triangle. It's the one that's across from the right angle, which means 13 is H. So, if I'm using my formula, I would probably say something like H squared equals A squared plus B squared. I don't care if you call it H or C. Either one is fine. I know 13 squared equals 5 squared plus B squared. So now I'm going to know that 169, again, that should be automatic, equals 25 plus B squared. So now what I'm going to do is I'm going to subtract 25 from both sides so I know what B squared is. So that's going to be 144 equals B squared. If B times itself is 144, what number times itself makes 144? Go. 12. So you could just know that, which is why I tend to try and use friendly numbers and just have you memorize it. But if you didn't, let's say it was root 144. You wouldn't know what that is. What you would do is you would say that the square root of 144 equals B. And you would leave it. If this wasn't a friendly number, you would leave it. But in this case, it really, really, really is a friendly number. B equals 12. So we know,
What B squared?
1 second. I know B squared is 144. That means B times itself is 144, and 12 times itself is 144, so B is 12. Or you would just hit square root 144 in your calculator. Now, looking at that, I know that this side is 12. So what does that mean about RT, which is what I actually need in order to find TS? Go?
It looks like RT's half of them.
In fact, RT definitely is half. It says in the question, and that's what these little hash marks mean. So what is RT? Go. 6. So if RT is 6 and RS is 5, can I find TS? I can the exact same way. So I could even look at this like it's a separate question now. Right? Where T, S, and R, that's 5, that is 6, and I need to know the hypotenuse. Now, you could do the formula again. And if you're the formula type, which I totally am, you could do the formula again, it would work out just fine. But I'm going to show you the kind of logic way, just in case you don't like using formulas. Okay? So, we're going to take this and we're going to make squares on each side. Okay? What would this square's area be?
It is
36. It would be 6 times 6. And what would this square's area be? The bottom. You can't see where I'm pointing. Sorry. Go. 25. So you'd label the area equals 25. Now this area is going to equal those two put together, because that's what we know based on the Pythagorean theorem. That the long side's area, if it's turned into a square, is the same as the other two squares added up. Go.
We have to do the opposite. Isn't there one where you subtract them?
Yeah, that would be if I knew H and I didn't know one of the other ones. But in this case, I do know the other
Sorry to
two.
interrupt, Miss Stevens. Can you contact the office, please, Miss Stevens? Thank you.
So 36 plus 25, go. 50, did you say 61? So the area is 61. So you're one step ahead of me. So what is the side length? The square root of 61. That's how long that side is. And if you left your answer at that, you're good. Square root of 61. Because some number times itself equals 61. What is that number? Well, it's the square root of 61. Make sense? You really, really, really that relationship back and forth. That square root of 61 times square root of 61 equals 61. And if a square has an area of 61, then each side is square root of 61. Know that completely. And if you don't, watch this video again or try it out a whole bunch of times until that starts to make sense.